offering managers in the IBM monitoring and management space. I'm primarily focused on the OMEGAMON offerings, and so that's the principal topic today. I'm going to be giving you a little overview of what we've been doing in the past 12 months, and then start to look at some of the problems you could solve, a couple of scenarios that OMEGAMON can help you drive to a solution with. So I'm going to start with a little bit of sort of OMEGAMON fundamentals. I'm assuming since you're all here, you have either some interest in OMEGAMON, you either currently use it, or you have used it in the past or are thinking of using it. So I'm going to give you a little bit of detail on that, and I'm going to focus particularly on what we call the enhanced 3270 UI, which is our strategic 3270-based tool, which the OMEGAMON agents feed their data to. So let's say, most of you probably will know what OMEGAMON is. It's a performance and availability management tool for products on Z. We're going to be talking about monitoring for zOS. We're going to be talking about some of the other capabilities that we have. So infrastructure-wise, storage and networking information, so details fed through from COM server. We also have now the ability to monitor Java resources, and also the key subsystems that you have on the mainframe, so like CICS and IMS and DB2 and MQ and so on. So the details are fed through to agents, and you can view this data on a number of user interfaces. We have graphical user interfaces, but we also have 3270-based ones, because our experience from talking with clients is that a lot of you out there enjoy using 3270. You like having the speed of response, and also being able to get to the information quickly. Well, I'm going to be talking a little bit about how you can proactively monitor your systems using situations in OMEGAMON, how we provide some of those out of the box, which are useful for you to use, but then you can use them as templates in order to tailor it to your systems, your installation base. So just a quick view of when I talk about the OMEGAMON family and how it fits into the overall IBM service management products. We have a number of OMEGAMON offerings. There's a lot out there. You can buy individual ones, but we also group them together in terms of what we call suites. We've got one that's focused on the infrastructure level, so looking at the zOS and the hardware, and also the networks of storage and the Java runtimes that sit above it. And then above that, we have the sort of subsystem resource management provided by the OMEGAMON Performance Management Suite. So once you're looking at also including CICS and IMS and DB2, etc. And then outside of that, we've got what we call the Service Management Suite, which integrates both the monitoring data that OMEGAMON provides with system automation, NetView, and asset discovery, and shows that together into a single dashboard system, which we call Service Management Unite. And OMEGAMON data can be used elsewhere. So although we have our user interfaces, we have the ability to feed that data through SOAP or RESTful interfaces, so that third-party tools can also access OMEGAMON data as well. So the data is available there as a reservoir to be used by other tools if needed. And so we're seeing APM tools and other tools that's almost in the DevOps area as well. So developers also might be interested in using OMEGAMON data that's collected so that they can understand the impact of their changes. Just a quick view of what's changed. If you were in my previous session, then you'll have seen this chart already, and I went through a lot of the updates of what we delivered in the second half of 2017. Most of the OMEGAMON products have been refreshed in the past 12 months, most of them in the last 6 months, in fact. So we did what we call the 5.5 release, which delivered updates for OMEGAMON zOS, CICS, messaging, IMS, and networks primarily. And then we also have an APM offering as well, which was called OMEGAMON for APM. It's now called zAPM Connect. I won't be talking about that one in particular in this session. I'm focusing on really what we call the core OMEGAMON products for providing that resource level details. So as I mentioned, OMEGAMON There are many ways to utilize that data that's collected by the OMEGAMONs. So for those of you who've used OMEGAMON for a long time and what you think of OMEGAMON is probably what we also deem the OMEGAMON Classic. So that is the ability to log on and look at a single address space or a single CICS region and look at the information about that. It's very fast and powerful. But it's a single view of things. Over the years, we've evolved that, and we see a lot of demand for information about plex-wide views as well. So you want to look at how details have been performed across the whole sysplex, or perhaps across a CICS-plex or IMS-plex. A lot of our newer offerings actually will show that plex-wide view as well. So there's lots of ways that you can actually look at this data. The choice of what the UI is really up to you as to, what is your role? Are you an operator? Looking at that, you just want to deal with the alerts that are coming through. Are you the subject matter expert who's looking at the deep dive information that needs to be able to resolve that problem quickly once you've seen that there is something to address? And that goes all the way from those classic UIs up to, you can see at the bottom there, the Service Management Unite web-based dashboard. What we're going to focus on primarily in this session is the OMEGAMON Enhanced 3270 UI. Another thing just to quickly call out about the latest 550 releases is that we've streamlined the architecture. And this is a really simple diagram, but I just wanted to sort of clarify what a typical installation might look like if you've deployed a number of OMEGAMONs. So on an LPAR, you'd probably have different agents for those tools that you want to monitor. So you'd probably have a monitoring agent for zOS, maybe storage and networks as well, running in what we call a remote TEMS or a Tivoli Enterprise Monitoring Server, and you'd have one of those on each LPAR. Then you'd also have monitoring agents for each of the subsystems you might want to be monitoring there. So, for example, CICS or DB2. Some of those older OMEGAMONs will still have the classic UI. The newer ones like networks or JVM will just have what we call a TEMA or a monitoring agent to collect the data and feed that back. And that data ultimately gets fed back into a single hub TEMS that you have for your enterprise. And then that then connects to the address spaces or the processes that are managing the user interfaces. One thing that we have removed in the 550 releases, and it's been a statement of direction for a number of years, is what we call the CUA or OmegaView interfaces. We hadn't invested in them for a long time. Our focus is on the Enhanced 3270 as the way of accessing OMEGAMON data using a 3270 interface. It's far more integrated between all the OMEGAMONs. They all feed their data into one portal, and then you actually just log onto this one address space and you can see all your OMEGAMON data on that particular portal. So with the 550s, if you are using CUA and OMEGAView, that's now been withdrawn, and you need to start thinking about moving to the Enhanced 3270. And hopefully this session today is going to help you understand a bit more about what we have in that UI. So let's take a quick look at what it looks like. And just as a quick show of hands, are people using the Enhanced 3270 today? Are there people who are using it? I see a couple of hands and it's tentative, so maybe you've got it deployed, but people haven't quite fully utilizing it yet, perhaps. It's almost like a GUI on a green screen, and there's some familiar things that you'll see if you're familiar with GUIs, but also there's a few things that you're familiar with if you're a 3270-based user. So this is what we'd call a workspace. It's got a couple of subpanels there. The workspace is called Address Space Overview. The subpanels, there's Address Space Counts and CPU Utilization Summary. And this is a workspace from OMEGAMON for zOS. There's a lot of things that you can point and click on. So you can scroll down, you can put a cursor in next to a particular row and put a keystroke in there to take you to drill down to some more information. If there's a cell that's lit up white, you can put your cursor on there, hit enter, and it will zoom you into that information as well. It's got some pull-down menus like you'd see on a GUI. It tells you at the bottom there what hub you're connected to, so what system you're looking at. And you can see in the top right there, it tells you what plex you're looking at and what the SMF ID is of the LPAR that you're looking at. Now, obviously, that's in the OMEGAMON for zOS thing because that's looking at plexes and LPAR names. If you're looking at an OMEGAMON for CICS workspace, those two fields actually will tell you, what's the CICS plex and what's the CICS region I'm looking at. So the context changes as you move around the system as to what details you're looking at there. And a lot of the things in here are fairly GUI-like. So if you see the little icons there, you can see that column is sortable. And if there's that little green thing there, that you can actually then look at that column is filterable. And you can press the PF4 key, and it tells you what columns and what fields can be filtered on. And you fill that information in, and it will obviously filter out the details of the data that you're looking at. You can also have cells highlighted in certain colors, so you want to draw that attention to. So there's the ability to customize thresholds to say, okay, if CPU is above 40%, make sure that cell is always highlighted red. That's not an alert as such, but it's when you're looking at the screen, you can actually see, have it, be an eye catcher on the screen so you can see things. So all these things are fairly simple things to understand. Where the power of the enhanced 3270 comes in is, as I said, we're pulling all the OMEGAMON data into one UI rather than having separate ones for each OMEGAMON and having perhaps some slightly different knowledge required to actually access the data on the different classics. We're showing not just the information together in the same UI, but actually starting to integrate things better. So this is what we call an embedded subpanel. And this is actually an OMEGAMON for CICS workspace, because you can see in the top right there, it's got CICS plex and region names. So I'm looking at a CICS region. The workspace is called CICS region overview. We've got some tabs here, so we can do tabbed workspaces. So just like you would in a GUI, you can click through the tabs. There's 3 of them there: CICS region, zOS address space, and data sources. And if you just had a OMEGAMON for CICS installed, all you would see is that top subpanel, which says CICS CB07 zOS address space. And that's information that a OMEGAMON for CICS knows about that address space. So the OMEGAMON for CICS agent knows that a little bit about what the address space is doing. Not a huge amount, but it's giving you some information there. That second subpanel is provided by a OMEGAMON for zOS. And because you've got both products installed, and it's able to say, okay, I'm looking at some address space information about CICS CB07, it's asking a OMEGAMON for zOS to tell me some more information about that. So you now have additional information provided by a second OMEGAMON agent to actually give you more context around that details and how you can understand potentially what you're investigating here. You can see it's kind of partly covered up by one of my labels, but you can see that top line of that second subpanel is white. So at that point, you can put your cursor there, enter that, and it will start taking you to the OMEGAMON for zOS workspaces. So you started looking at something in CICS, but actually you want to look at some more details about it from the zOS side. Well, just navigate directly straight into it through here. And we've got lots of other points where we have this kind of integration between the OMEGAMONs. So you might be looking at a CICS region, and that particular CICS program is writing some information to an MQ queue. So if you have both that OMEGAMON CICS and OMEGAMON for messaging together, you'll see the integration between those points there. Same with perhaps CICS and IMS and DB2 and MQ and DB2, for example. One of the key things that OMEGAMON provides, or has provided for a number of years, is history. So the ability to take snapshots of the data it's going through and then actually look at that. And in the 3270, as you're looking at the real-time data, you can say, bring up the history for this particular workspace, and it will tell you when the data was recorded and what data we have there, and then you pick which time slot you want to go into detail, and it brings up the same workspace, but it's giving you the snapshot that occurred at that point in history. And you can see that it's a history view because in the top right, it's now got a little sort of sky blue display, and it just says, I'm looking at history. The other thing to notice is that at the bottom of the workspace, it's telling you what time you're looking at there. So it's showing you at 1 o'clock in this case. And then either side of that, it tells you when is the previous snapshot of history and when was the subsequent one. And you can put your cursor there and hit enter there, and it will take you to the previous snapshot. Or you can go to the move forward as well. So being able to move forward and back in history as well to look at the previous and latest snapshots. And you could also, provided you collected that data for other workspaces at that time slot, navigate around as if you are looking at that data at that point in time. So you don't need to say, well, I'm looking at this one now at 1 o'clock, then go back to real time and go to another workspace and then go and look at that at 1 o'clock. You can navigate around as if you're looking at it at 1 o'clock at that point. There's a few other little functions that various OMEGAMONs have. So one other is we have a search command, or find as it's called there, where you can look for certain information quite quickly as well. So let's say you want to look at something in CICS, and I want to find out some details about a particular program. I can type in the find prog and then the name of the program, and it will take me straight to the workspace that tells me, here's what I found about that program, here's where it's installed, and some details about it. So you might be able to, for example, you might be thinking, there's been a complaint about some of the programs, and you found out, oh, actually, we loaded in new versions on certain CICS regions, but we missed it on a couple of them, and that's the problem there. So you can quickly get to details on certain resources just by using a find command. And there's certain unique features that each OMEGAMON has brought in. So one of the key ones in OMEGAMON for IMS that we've added in the 550s is what we call IMS Commander, which is a replacement for the ICF function that was in the OMEGAMON 2. So that's the ability to issue IMS Type 1, Type 2 commands straight into the console, and you get the output on from the IMS console straight into the E3270. And then you can then sort and filter and search for messages within that so that you can actually manage your IMS systems quite quickly there. Some of the other things that are in there, there's OMEGAMON for CICS has a bottleneck analysis tool. OMEGAMON for zOS has an inspect tool that you can look and see look more detail at what modules were loaded into the particular address space. CICS has a resource limiting tool, so that, and this was in previous versions of the OMEGAMONs, but we've now made available into the enhanced 3270. So resource limiting, you can set up certain parameters. So if a task is starting to consume a lot of CICS resources, it will take immediate reflective action on it. Another one in OMEGAMON for zOS is the memory display and zap function. So if you want to look at a particular bit of storage and see what's listed in there, you can do that. And then if you have the requisite RACF permissions, you can then also take action and zap that storage as well. That was a powerful tool that's in previous releases, and we've now made available in OMEGAMON for zOS 550 as well. Just one thing to call out, I'll be talking through a few of these things, but if you're getting started with Enhanced 3270, we've been running a number of webinars for the past 18 months, about once a month, where we focus on a particular topic around it. 1 month it might be about OMEGAMON for CICS, another one it might just be generally about how to customize workspaces. It's just a 1 hour session where you can bring your questions and ask us about, I don't understand how to do this, which I used to do in the older UIs in OMEGAMON, and just talk directly to the developers for 1 hour just to get some insight into that. So if you follow that URL, that gives you links to all the previous sessions that are available on YouTube and DeveloperWorks, and you can sign up to be alerted to the next webinar that we'll do probably in April or May. Okay, so next thing I want to talk about is, well, how does OMEGAMON collect data? Because that kind of helps us understand how to tune the system and do some best practice. So ultimately, you've got agents deployed on each LPAR that you want to find out information for. Data is requested in 2 ways. One, it's on demand. So you're navigating to a workspace and you go, okay, I want to see information about some storage information. That then sends a request to the hub terms, which then sends a request to various agents to collect that information and feed that back up and show that there. So reports that you want to see on the TEP or on the E3270 or other UIs are all driven that way. There may be third-party tools that are using our RESTful interface or our SOAP interface that are also making on-demand requests for data. The second way that data is collected is scheduled. So I've already mentioned the historical data collection. So you set up profiles that say, I want to collect information about these details every 5 minutes or every 15 minutes. And by setting that up, then on those time slots, the hub TEMS will then make the requests out to the various agents to collect that data. The other scheduled data request is for situations, which we'll go into in a bit more detail, but situations are where you want to find out how your OMEGAMON system, or how your system's performing, and you want OMEGAMON to alert you to a problem if there is a particular problem. So you want to tell it to go and keep an eye on these particular attributes and collect that on a scheduled basis, and then when it comes back, the TEMS will then analyze it and say, yes, this is above a threshold that we need to be alerted about, and then generates the alert for it. So I mentioned attributes there. So what do I mean by attributes? So every OMEGAMON product organizes its data into attribute groups, which are sets of kind of logical bits data that go together. So for example, details about a CICS program or an IMS component or some kind of DB2 table information. By grouping those together, when data is collected, the agent either receives an SQL request to actually collect that information, and it gets all the information about that particular attribute group or attributes within it, and then sends it back. So these attributes provide a lot of both system level information, but now increasingly more sysplex level information as well. So you can actually look at that, and then once that request comes back, you then put it into the workspace or to define the situations from it. So they're kind of like database fields and tables, and being able to actually collect those data points for you. You can find out what attribute groups are out there by going and looking at the knowledge center. So here's just a quick example from OMEGAMON for CICS. There's a bottleneck analysis attribute group, so collecting details about how what's been about particular tasks that have been running for a period of time. And the sort of details that you'll see there are things like what is the long-term percentage of transactions are spent in a certain period of time, who called it, what was displayed, what's the threshold. All of those are listed there for each one, and then we have workspaces that are predefined that will collect a lot of these things, but if you're trying to customize it in order to look at a particular set of information that you're interested in, you might want to consult the knowledge center and work out what bits of data you want to collect and actually put in your workspace that you're editing. So this is just a quick, very simple animation of how the whole request on-demand request process works. So here we have the user sitting at their workstation, and they navigate to a new workspace that they want to collect some data from. So they either navigate or hit refresh. That then creates a query that says, I want to collect this data from these attribute groups in order to populate this particular workspace. The request is then sent to the monitoring server, which says, okay, for that request, I need to talk to these particular agents because you've said I want data X, Y, and Z from CICS regions A, B, and C. And so it will then route that through to the particular agent. Then when all the data comes back to the hub TEMS, it then pushes that back to the user interface and says, here's your data, do with it what you will. And so what the interface will then do is if there are any filters that need to be applied, if there's any thresholds that need to be applied, and how it wants to be displayed, then the user interface address space or process is responsible for displaying that. And then ultimately, then you get the refreshed workspace on screen. So I mentioned situations briefly at a high level. So situations are OMEGAMON's alerting mechanism, so where you define a set of conditions you want to examine to determine the potential problem that you want to look at and how you want to address them. The main thing for using situations for is that it helps you proactively monitor the system. So nobody wants to sit there looking at a screen of numbers and working out when things are going wrong. You want to be alerted to the fact that there's a problem because OMEGAMON is doing the work for you and tells you that actually now things are beginning to spike in a certain area. You probably want to go and look at this particular IMS region because something's happened. You can then sort of decide which metrics you want to monitor and which systems you want to run on. So you don't need to decide that you want to see it on every single IMS region you want to test on. You may want to define a certain policy that says, I want these situations to run on these systems on work days, these ones to not run on test systems because I'm not interested in alerts on test systems, these situations to run on on the weekend perhaps, or certain, you can define these policies that will tell you which things you want to test for and when you want to test for them. Then if there is a problem, you can actually decide whether OMEGAMON should take the action for you. So there are aspects where you can say reflex automation. So if something goes above a certain level, I want you to kill this particular process or generate something to respond to it. Or you can leave it to the operator to actually do the command that needs to fix this. Or you could get it to write a message out to the syslog so that then your automation tool can then say, all right, I read this, OMEGAMON generated an alert that said, CICS region A, it did this, and you've defined your policy in your system automation tool to then respond to that and bring up a new CICS region or take something down or however you want to do this. The situations can also provide what we call expert advice as well. So you might have operators who are not so familiar with the system, and so when they see the alert that appears, it'll say, okay, something's happened here. These are the things that you need to check for now as you investigate this problem. So it's not reliant solely on the person responding to this to understand what's going on. You could have leveraged what the experts have done in the past and provided some expert advice that when that situation occurs again, the person who's dealing with it can actually learn from that and understand it. So now you can, situations are available on every user interface, and you can create them on whichever user interface you want. Traditionally, they were created on the Tivoli Enterprise portal, the graphical UI. We've now made that available in E3270. And if you create it in one place, you can see it on both places. There's not two different alerting mechanisms here, it's just the same details, but you choose whichever tool you're most comfortable with for creating and editing those situations. So every OMEGAMON product provides some situations out of the box, and you can deploy those and use them straight away if you want. You can just say, okay, enable these and allow those to be used. When we defined it, we're trying to make those out-of-the-box situations as useful as they can be, but they're not aware of the subtleties of your particular installation base. So some of them will require, well, I would say that you should consider those templates to start with and make customizations appropriate to those environments so that you actually get the levels tuned to the sort of alerts that you want to see. And there's some key things you have to think about when you're talking about situations. You know, they're only as useful as you want to make them be. If you switch everything on and then you get lots of alerts all over the place, think about how that might help you, or does it hinder you? So one of the more difficult things when I go to a customer site is you have there's a red alert on in the corner, and you go, well, We know that's a red alert, but it's not really a red alert because it's always on 24 hours a day and it doesn't really matter to us, so we know to ignore that one. Well, if you know you're ignoring it, then switch it off and don't get that alert ever again, because you end up not being able to see the wood for the trees because there's lots of other alerts on there. If it's always going to be firing alerts, then it's obviously that OMEGAMON is out collecting information about that thing, and so if it's not important for you to collect that information and be alerted to that, then don't make OMEGAMON do that and save the MIPS and test for things that are actually correct. Make sure that the thresholds that you're testing against are right. So we pick a setting that might say, well, if CPU goes above 40%, then alert me. But you might want to be more sensitive and say, okay, if it goes above 10% for these sort of address spaces, tell me about that. Think about how often you're testing the conditions for. Is this something that changes every 5 minutes, and so you want to be alerted to something quickly? Is this something that's more gradual, and you can say, well, actually, I only need to test this every 15 minutes because it's not really that important, but when it happens, I just want to be made aware of it. Think about what systems you're testing against. So do you need to test it against all your development systems or just the production systems? So also think about that particular aspect. And then also around if you're using multiple situations to test the same data and maybe testing them at different intervals as well. So that you might have an alert that says, okay, well, give me a yellow warning if it goes above 20% and a red warning if it goes over 30%. Do you need to use both of those conditions, or do you just want to have the 20% one in there or just the 30% one? So think about how these things are being done. Try and avoid some of that duplication of effort and improve that. So I think I've spoken to some of these, but around about distributing the situations and how you think about setting things up. There are a few things just to be aware of. So when you're trying to test against certain conditions, for example, if you're testing against a numeric value, like it went above 30%, that's far more efficient than testing against an attribute that's maybe returns a string of something and and then OMEGAMON has to do a string comparison to work things out. So there's some little subtleties in understanding how to make the situation as efficient as possible. We do have a best practices guide that our performance guy, Rocky McMahon, puts together. I recommend you going to download that. It's just a PDF. He updates it about every 6 months, which has a list of the situations that he finds are most useful with customers. So we get those ones out of the box, and they would say, of those 50 that we provide out of the box, I would recommend putting on these 10 as the first ones to start with and see where you go from there, that sort of thing. Okay, so that was a kind of introductory view of what the enhanced 3270 can do, and also how situations work and how OMEGAMON collects data. What I'm going to start talking about now is putting some of that into practice. I'm going to show you a couple of scenarios that you can use with OMEGAMON and just show you how a lot of the things that I've just shown you actually come together and help you solve some problems. So I'm going to start by looking at an alert that triggers. And this is the situation status tree that we delivered probably about 2 years ago now. It is a dashboard view on the 3270 for showing you what situations are currently active and which ones have been active in the sort of recent past. So down the left-hand side, we've just got a basic navigation tree, which just breaks down the system into the different subsystems. So you've got CICS and CTG and zOS and etc. Looking across where you get the colors, in the fourth column is the current status, or the fourth and fifth columns are both the current status. There's a color one and there's a word that tells you what the current state is. And that's showing you if there is a critical alert that's out there or a warning alert or things are green on that system. So you can drill down and see which situation might be open. The two columns in the middle, which have got a lot of the color there, is the recent history. So it will be caching information about situations every 5 minutes to say which situations were alive at that point. And then a more sort of summarized view in column 2 where over the past 4 hours by default, what was the worst situations that were triggered at that point. You can go and drill down and look at that information because it's cached, and you can say, well, I noticed that something happened at 7 o'clock this morning and then it disappeared. If it's still in that cached state, then you can then go and look and see what happened at that point. And on the summarized one, you can increase that time span. So you might want to say, well, I want to keep the last 24 hours cached. So if something happened overnight, it wasn't important, but when I come back in, I want to look at that and understand what was going on. The tree on the left-hand side is also customizable. It's just a basic JSON structure. So we give you the sort of physical view out the box, but you might want to logically break it up into applications, or if you're grouping systems together into some geo or something like that, you can group your situations quite easily into different ways of looking at things. The key thing about looking at that recent history is if you might have a situation that flickers on and off over time, and you're like, well, it was active a bit, and then it disappeared, and then it came back, and then so you can see if you're on a threshold of something there. So what we're looking at here is we have an open situation that I've got highlighted in the green box, and it's a critical situation because there's a little red icon at the end there. We can see that it's been on and off a little bit over the past few hours. So there's some, let me see if I can get this, there you go. As we go back in time, we can see it was green for a little while, so that means the situation was closed, but it was open a little bit earlier, and then over a period of time, actually, it's been open and closed quite a lot. What we can do here is then put our cursor here and say, let's go and have a look at what the situation is and try and understand what was going on. Well, before I do that, just a quick view of, this is actually the first screen that when you log on to the Enhanced Data 70 you see. So you get this dashboard, but then you also got the tabs for each of the other products you've got installed. So this system's got them all installed, so you can just go to, if I'm interested in CICS information, I just go to the CICS tab, and then you get the CICS information at that point. So I'm going to look at the situation here, and it gives you the details about that situation. What was the condition that was trapped when the situation first tripped and came on? And then what's the current situation? So if things have got worse in that intervening time, it'll tell you what the current situation is. Or if things have got better, then it'll show you that as well. So we've now taken a look at the data there. We can see that actually this is looking at CICS service class information, and we've got a really bad performance index here that's exceeds the threshold that we're looking at. So this is the state when it initially happened, and we can see in this bottom one, it's still a live issue here. So I'm going to look at this and then say, okay, being the CICS expert, I'm going to investigate this particular service class problem. I can see that the service class group is something called Y-trans. So I'm going to look at that, and that's where I'm going to focus my information. So I go to the CICS service level analysis workspace, and I go and look at the Y-trans and understand what transactions are in that grouping and what's the response times there. So we can take a look at this, and I say, okay, in this group, I can see some of these transactions have got a pretty high average response time. I'm going to take a closer look and see which regions they're running on and which and details about what programs perhaps that those tasks are running. OMEGAMON for CICS has a task history function, so as you can then record details about the tasks that are running through the system. You can switch that on and look at how those tasks are performing, and then look at the details about what that task was doing. So what was the response time of it, how much storage did it use, what else did what other information did it connect to, and things. And then you can also turn on the application trace facility as well, so you understand what CICS calls are being done while this happens. So I'm going to look at an example of a task that's been captured that's using those transactions that solves a problem, and then go and look at the application trace for it, and I can see that it goes from one CICS region to another as it calls switches regions, and then in the end it'll show you at each timing interval where the delay was while you were trying to capture this. And so, for example, it might be something like, well, we made a call out to DB2, and there was a slow response time coming back from DB2, and that's what caused the whole task to be 7 seconds long as opposed to 0.2 seconds. So at this point, we then go and look at the DB2 system that's being connected to here. This is another example of the embedded workspaces that I was talking about. So this is a CICS view of the DB2 connection. Because we have both OMEGAMON CICS and OMEGAMON DB2 installed, we can see the information, what OMEGAMON DB2 thinks about that particular connection as well. And we can either then go into OMEGAMON DB2 details to find out what's slowing down within that system, or we can go and pass the buck over to the DBA and say, it's your problem now. But these are the details that you need to go and investigate the problem. So what happened there? Well, we got an alert generated by OMEGAMON because our SLA analysis said that we were performing too slowly. Doing some of the investigation within OMEGAMON for CICS, we found out that it connected to a DB2 program, and then as we went through that, then we can then send that response over to DB2 to fix. Just a very quick way of going from the alert through to a problem where the symptom might actually be in one area, but the root cause is somewhere else. I'm going to give another quick example here. This is using OMEGAMON for messaging. So we get another new alert coming in here. And hopefully your systems won't have as much red on as this one is, but this is our development system. So it's kind of lots of stuff is switched on, and it looks a little bit more like a Christmas tree than it probably should do. But we're looking at this one here called MQ series Q high depth. And it's just tripped, and we're going to have a look and see what the issue is here. So again, we put our cursor on there and hit enter, and it takes us through to the information about it. First thing it says when we're looking at this information is that actually the useful information is actually way off to the right. And these little arrows here tell you that you can scroll up and down or left or right within that particular subpanel. Now, if there's an eye catcher that's off to the side of the screen that you can't see, then it will highlight that in red and tell you that there's something red that you can't see. So you need to scroll to the right. And as we scroll to the right, the event comes in, and we can find out some information here. So we're looking at this and we go, okay, we've got a high Q depth, then we need to look at Q821 and have a look at that particular queue manager to see what the issue is there. So we navigate to the OMEGAMON for messaging health overview, and we find that particular queue manager, and we see that actually, yeah, there is a health issue there that says it's critical. So let's drill down and take a closer look at what's going on. Normally, if you put S next to it, that's the kind of the default view for drilling down there. If you put a slash in there, then that'll bring up a menu of things that you can then drill down to for that particular system. So we're going to drill down, and now we're looking at the Q manager statistics, and we see, yep, Q health is critical, and we have a queue, at least one queue with a high depth there. So we're going to try and have a look and see what's going on there. We put our cursor on the high depth queue count field and hit enter, and that will drill us down a little bit further. And here's some details about the queues. So the bottom subpanel is telling me, well, here's all the queues that have got something in it where the depth is greater than 0. And then the top one tells us if we've got any that have been marked as having a high depth. And so this one here has got 3,500 odd items on the queue. Let's have a look and see what this queue in particular is doing. So now we've drilled down to the queue status details, and this is a tabbed panel with three tabs there. We're looking at it. There's still some details around what this queue is doing. We can see there's still some more things being added on there. How long it might take until this queue gets full. How full it is at the moment. It's about 72% full. And then at the bottom here, we can see which applications actually have an open handle to it, which would be either writing or reading from it. So there's a couple of applications listed here that we might have to investigate as well. We'll look a bit more about the statistics. So how quickly are things being put onto the queue and how quickly are things being written off the queue. and how much time we've got left until we think that if nothing changes, we'll get to a full queue. Just some basic information there. So let's go and look at these applications that we're writing to the queue. And so we'll take a closer look at it, and we'll look at this one application called APM2isGet. Again, this is MQ information. This is OMEGAMON for zOS information. So it's just giving us some more information about what particularly that application with an 8-character name is actually doing, because MQ doesn't really know what it is. It's just an application at the end of the day. But if you want to go and look at, see if that's what that application is doing, we can jump into OMEGAMON for zOS to look at some more details. So then we take a look at the history. So is this thing writing lots of times to it, and then it drops down? We take a look at it and we say, oh, actually, we must have missed some times in the past, because actually about an hour or so ago, it actually was full, and then it dropped down, and then it's going back up again. So this sounds like we have an application that there's bursts where there's lots of things written to it. So we might want to just, let's try and solve the problem to start with, and then we'll have a look at the root cause afterwards. So we go to the queue, and then we can then do a take action on it. And you bring up the options menu by putting a /, and then there's some take actions you can do. So we're going to look at that. And then the second thing that comes up is some pre-populated actions you can take. So clearing the queue, enabling, disabling, preventing things to be written and read from it. Or you can just issue a straight MQSE command if you know what you want to put in there. What we're going to do here is just make sure that we just give it a little bit more excess capacity so that we can let the application carry on working with it, and then we'll maybe go and look at the actual root cause afterwards. So we're going to pick the option to change the maximum depth, and we're going to double it up to 10,000, issue the command, and the command was successful, and the details were sent through MQ. Now we go back to the high depth summary. Well, we still got the queue's still got stuff in there, and it's still writing to us, so it's about 4,400 there. It's not listed as a high depth queue anymore, and that's because the depth, that allowable depth now is 10,000 rather than 5,000. And we can look at this now, and it says, oh yeah, it's normal. It's about 45% full now. So at that point, we've quickly prevented a slowdown or a problem by extending the size of the queue with a couple of commands. We need to go back and try and fix the underlying problem, but there shouldn't be a problem now where the application can't write to the queue because it's got full. Next scenario I'm just going to quickly look at is looking at CPU usage and the rolling 4-hour rolling average that is very important to a lot of customers in terms of understanding what application is running there, and if there's anything going out of control, it's going to push up my rolling average. OMEGAMON for zOS provides a lot of information here. So here I'm just starting by looking at some LPAR information for our sysplex. There's nothing particularly bad happening here, but you can see the average CPU percent per LPAR and how much of the MSU capacity is being used there. So there's nothing to be concerned about here, but we're going to just really jump in and have a look at some of the data that we have. So picking a particular LPAR and then say, I want to look at the 4-hour rolling average MCU statistics, which are collected by RMF and fed through to OMEGAMON. And this will bring you up to this particular workspace. It tells you, what's the current state of the LPAR, which LPAR groups is it in, and if there's a grouping that's set together so that there's a soft cap for particular LPARs to be grouped together and used there. That will be shown. And then we also have the 5-minute intervals for the past 4 hours as well. So if you can see, it'll have a nice summary view here where it tells you, how much is being used, and if you were close to any kind of capping there. And then you can go to each of the 5-minute intervals for more information at that point. So what we're going to do is pick one of them in turn, and then we'll go and have a look at this. And this is for a 5-minute interval, and here we are, we've got the CPU utilization. And it'll tell you which of the jobs are running at that point and how much CPU they were using. this isn't a particularly exciting system. There was one TSO job that was running that was using a lot of the systems, but if we wanted to, if there was a particular problem that we wanted to investigate, we could then go and look at more details about that particular address space, what it was doing, who was running it, what was it a CICS region, was it a JVM, as I can see there on the second time. Then we can maybe start to look and see what the problem is perhaps with that system. We can collect lots of different information from source from RMF and also from OMEGAMON as well about details of the address spaces that over that 4-hour period. So we can look at not just the CPU utilization, but details about what the statistics on the LPAR were, job history information, storage information being used by it, so how much real storage, and also details from workload manager as well. And then also what we've added in 550 is the ability to also look at what devices and other adapters were being used by those applications in that period as well. So here we can then start to look at the history information about the address spaces in that LPAR. So not just the CPU information in terms of how much it was being used and whether it was zip offloaded and other useful details about what that address space was doing, but then also we can start to look at the storage that's being used as well. So if there's a particular address space going out of control or using a lot of storage, you can set an alert based on that to look at it. So typically what we find a lot of customers do is they set an alert around some of the capping or levels before they get to the actual caps that are being set, but actually a baseline around what CPU is being used for the 4-hour rolling average, and if you go above that particular level, let's get OMEGAMON to generate an alert, and then after that you can start to investigate what's currently going up at that point. Yeah.
Can you track the variable that gives you time to capping?
So the question is, do we have the variable time to capping? I would have to double check on that one. It may be other.
Really useful because you don't want to
Yes.
And be nice to be alerted before that.
I'm sure we have it then. I just need to double check it. Yeah, I don't know. Yeah. Okay, we've got a few minutes left. I just wanted to do one last scenario around Java problems. So OMEGAMON for JVM is a brand new offering, or not brand new these days. It's been out for a year. Still is relatively new when some of the OMEGAMONs have been around for 30 years or 40 years even. You can see all the different Java that's now running on your system, from zOS Connect to CICS to just Java batch applications out there. And we can also see if there's a particular problem. For example, in this case, we're going to identify a Java heap issue. So here's a job that we've got running. We've got 4 Javas running on this system. 2 of them are zOS Connect running in CICS. We've got a batch application that's a bank thing. And we've also got this one, which is suspiciously called Leaker1, but is a Java batch application. And we're looking at what's happening here, and we've had an alert, and it says, this application is performing a lot of garbage collection at the moment, more than average. So it's obviously thrashing around doing stuff to try and free up some memory. So we take a look at it and go, yeah, garbage collection per minute is pretty high. Percentage time in garbage collection pauses is creeping up. 0.14 is actually pretty, well, compared to the other one, it's not the worst one there, but it's still pausing. Heap occupancy actually looks okay. That's the amount of memory that's being used by the heap after a garbage collection. It's high, but it's not unduly high at this point, but the GCs per minute is suspicious to us. So we're going to take a quick look at the history view of that. So what have we collected over the last couple of hours, perhaps around what this job is doing? And we can see actually from 12:25, it's actually doing 12 garbage collections per minute, and now it's up to 32. We can also see a similar trend where the percentage time being wasted in a GC is creeping up. And also we see the heap occupancy now going from below 20% up to 70%. So this is a real clear sign that's something is not right in this application. It started off okay, but over the course of 30 minutes or so, it's spending a lot of time, increasing amount of time doing garbage collections, and it's not freeing the amount of memory that is expected. So we seem to be on course here for a out of memory condition and the JVM to then a bend. So we're going to take a quick look before the problem really gets too bad about what have we got set up in this JVM. And we look at some more details around it, and this is a look at the environment details that have been set up for that JVM, so things like the environment variables, system variables, what's on the class path, and what was on the command line as well. And we take a look and we see that, yeah, this JVM was actually only allocated for a paltry amount of memory to start with, and it's actually got a maximum heap size of only 128 meg. So it's actually running out of space quickly. We've not given it enough memory to work with the workload that it's generating, and we're leaking. So we can increase that maximum heap size and hopefully improve that. But underlying it, we think we've probably got a memory leak here. So we can capture that and show that the application developer and see if there's a particular problem that we need to track there. So, in summary, I hope I've given you a good overview of what we've been delivering with OMEGAMON. I'd encourage you, if you are an existing OMEGAMON user and you haven't moved to 5.5 yet, to start thinking about that. There's a number of updates that we've delivered which will, both performance-wise, but also technical updates such as improvements to the enhanced 3270. That is our interface for 3270 users going forward. We have removed the CUA in OMEGAView. There are no plans to remove the classics, just to be clear on that, but we're not doing enhancements there. You're not going to get sysplex wide views there, or CICS wide views, or IMS-plex wide views. So if you're wanting to use 3270-based interface into OMEGAMON, that's the direction we're going. It's far more integrated than the other ones were. The 550s, because we have removed the CUAs in OMEGAView, has reduced the number of address spaces that OMEGAMON requires to run, so it's simplifying the whole portfolio. That makes things far more lower cost of ownership to drive. Then we also spoke about some situations as well, so using those situations and tuning them well, taking our out-of-the-box ones as a template, allow you to proactively monitor that. They're the same situations that you see on the TAP, which you see on the E3270, which you see on the Service Management Unite dashboard, which I know I didn't talk about today, but is also available as well. And then we also went through some scenarios that showed you how that integration of having all the OMEGAMONs together in the same UI gives you a much richer view of your environment, and they actually are not working in isolation, but actually working together to give you that view. Finally, a quick call to action around this. So I mentioned the webinar sessions, and I mentioned the best practices documents. The links are in this documents, so if you just download that from the share site, you'll be able to get that. The one thing I didn't really talk about was Z trial. If you were in my last session, I mentioned it a little bit more, but we now have a Z trial, which is a free, easy, no work on your side to provision demo system for OMEGAMON for JVM, which also includes the E3270. You can sign up today, and you'll probably have access to it by the end of the day in order to look at, we have 4 guided tutorials through learning about how to use OMEGAMON for JVM and the 3270. Very easy way of doing this. And the other thing would be the lab sessions also as well later this week. So we have a number of sessions coming up. There's a lunch and learn tomorrow where we'll be talking about a lot of the newer things like the Java monitoring. But we also have some labs on Wednesday, lunchtime, afternoon. There's a whole 3-hour session booked out for OMEGAMON sessions. You can turn up at any point during that 3-hour slot to take whichever of the OMEGAMON automation analytics labs that you want to do. We also have a focus group this week on Wednesday. If you're interested in given us some feedback on how you interact with us and like to work with IBM in terms of direction of products. You can register for this focus group on that URL, and I'll make sure that that's available on the upload as well. Last thing, there's the URL for the Z trial program as well, and the webinars. So all that information is available on the slides that I've uploaded. So, within any further questions before we finish up? Yes. I mean, the questions around moving from CUA to E3270, is there a particular area that you feel like you don't have support for doing this, or is there a gap? Because okay. Uh-huh. Uh-huh.
Running about 676 regions on 5 CPUs.
Mm-hmm.
Just not like just 3, just 2.
Mm-hmm.
So we've been a big CUA user.
Mm-hmm. Have you used?
We want to extract the thresholds we have set up for all of our regions into 3270.
Mm-hmm. So you're not using situations per the TEP at the moment?
TEPs right now,
Mm-hmm.
but our operations who monitor all of our production mix environments have command monitors and terminals.
Mm-hmm.
We don't have PCs or units
Right.
to support it.
Right.
So now I have to replace the CUA interface for all of their access to our CICS regions with something that they understand instead of this 3270 extended out of the boxes
Mm-hmm.
Christmas all over the red.
Yeah.
It has nothing to do with our threshold settings that we've taken some decades to create.
Okay. We should talk. But yeah. We don't. Yeah. Okay. Thanks very much.
Because we share. Because we share.